Welcome in dark core. When it comes to dark matter and dark energy, there's more unknown than known. What we do know is that there's some mysterious force at work attracting and holding galaxies together, while dark energy is accelerating the universe at the same time. But neither one of these mysterious particles has been detected. But now some scientists believe that dark matter might be swirling around the edges of black holes, and other physicists believe they have found dark energy right here on Earth, and some say dark energy might not be real after all. Could it be true? Get ready to find out the answers to this and more. Logo. What is dark matter? If physicists had a most wanted list, dark matter would be at the very top. This is because dark matter is a theoretical invisible material that should be everywhere throughout the cosmos. In fact, just 5% of the cosmos is normal matter, 68% is dark energy, and the remaining 27% is thought to be dark matter. Dark matter and dark energy are the yin and yang of the cosmos. Dark matter produces a gravitational attractive force, while dark energy produces a repulsive force. The mind-blowing thing is that these theoretical particles make up 96% of the universe, and yet we can't see either one. This is because dark matter and dark energy doesn't produce, absorb, or reflect any light, meaning it has no interaction with an electromagnetic force. So, if dark matter is invisible, then how do scientists know it even exists? The only clue we have that dark matter exists at all is because of the gravitational effect it has on celestial objects in the universe, like stars and entire galaxies. Think of dark matter similar to the way you see the wind on trees. You know there's wind because you can see the leaves moving, but you can't see the wind. NASA researchers have observed certain star clusters exerting far more gravity than should be possible based on the amount of baryonic, or visible matter they contain. NASA claims these observations wouldn't make any sense without dark matter. Now, the idea of dark matter isn't relatively new. In fact, the first clues of its existence came in the 1930s when an astronomer named Fritz Zwicky was looking at a distant swarm of galaxies that make up the Coma cluster and noticed something very strange. The galaxies were moving fast. In fact, they were moving so fast that the clusters should fly apart, but they didn't. This led Zwicky to believe there must be some unseen material hiding among the galaxies holding them together with some gravitational force. In the 1970s, another astronomer made the same observation. Vera Rubin found that stars were swirling around spiral galaxies much faster than expected, and to avoid shredding themselves, there must be some unseen force holding these galaxies together, possibly the gravity from dark matter. From that point on, many researchers became convinced that dark matter does exist, and many different types of particles have been proposed to explain dark matter. But so far, those experiments have only ruled out contenders, and we're still empty-handed on the subject. But now a new study says that dark matter may not exist at all. New study in the study. Scientists found small discrepancies in the orbital speed of distant stars that show almost no gravitational effects. Basically, the study shows it could be our insufficient understanding of gravity that is behind the gravitational strength of both galaxy clusters and known galaxies, rather than clouds of dark matter. There's something else that might put the brakes on the whole dark matter scenario. Astronomers just discovered a galaxy that has no trace of dark matter, or what we think dark matter is. An international team of astronomers were looking at the galaxy AGC 114905 and took detailed measurements over a course of 40 hours using state-of-the-art telescopes. In fact, what they found was 6 galaxies with little to no dark matter. AGC 114905 is about 250 million light-years away and is classified as an ultra-diffuse dwarf galaxy, referring to its luminosity and not its size, as it's about the same size as our Milky Way galaxy. However, it contains 1,000 times less stars. The prevailing idea is that all galaxies, including ultra-diffuse dwarf galaxies, can only exist if they are held together by dark matter. But using the standard way to reveal dark matter, which is by measuring the distance of the gas in the center of the galaxy on its x-axis and the rotation speed of the gas in the y-axis, the team of researchers found that the motions of the gas in AGC 114905 can be explained by normal matter. However, the problem remains that theory predicts there must be dark matter in galaxy AGC 114905, but observations show it just isn't there. But there are some possible explanations for the lack of dark matter. One example is that the galaxy could have had its dark matter stripped away by another large nearby galaxy. The problem with this is there are no nearby galaxies. Another assumption is the estimated angle at which researchers think they are observing the galaxy. Boson clouds, even though this could point to the end of the theory of dark matter, there have been some other new theories that might prove otherwise. The hunt for gravitational waves and ripples in space-time caused by major cosmic cataclysms could help solve another one of the universe's big mysteries called boson clouds, and whether they are actually dark matter. Researchers are now using powerful instruments such as a laser interferometer gravitational wave observatory, the Advanced Virgo detector, and the Kamioka gravitational wave detector to detect gravitational waves up to billions of light years away to locate potential boson clouds. Boson clouds are made up of ultralight subatomic particles that are almost impossible to detect and have been suggested as a possible source for dark matter. Researchers will try to hunt down these particles by searching for gravitational waves caused by boson clouds circling rapidly spinning black holes. These particles, if they exist, have extremely small mass and rarely interact with other matter, and that is one of the key properties that dark matter seems to have. By searching for these clouds, we might be able to track down the elusive boson particles and possibly crack the code of dark matter. Dark matter, one of the weirdest substances in the universe, just recently became more mysterious. Despite us not detecting it yet, a new study says that dark matter may come from regular matter. An older theory called freeze-out suggests that dark matter formed in the early universe when all particles were smashed together in a hot, dense soup called a thermal bath. The vast majority of these particles started off as dark matter, which was soon destroyed as soon as they came into contact with regular matter, known in cosmology as annihilation. The reverse of this theoretical reaction, in which dark matter replaced more abundant regular matter in the early universe, is called freeze-in. Researchers took this reverse theory to the extreme, suggesting at first that regular matter outweighed dark matter by a lot. However, that began to change rapidly. Using a theoretical model, when a particle of dark matter came into contact with another particle, it annihilated that particle and spit out two particles of dark matter. Now, this is similar in the way other fundamental particles, such as positrons and electrons, annihilate one another to produce two photons. However, this model produces dark matter at an exponential rather than a gradually slowing or logarithmic rate. If this is indeed a true mechanism, then it offers a solid explanation for the current 6-to-1 ratio of dark matter to regular matter. But that brings a big question. If dark matter converts everything else into more dark matter, does it mean that the universe is doomed to become one big dark matter blob? Because if it continued too long, you would end up with a universe with a lot more dark matter than our universe itself. However, this new theoretical mechanism only works at an extremely high temperature, as during the beginning of the early universe. As the universe cooled, the reaction ceased, and the amount of dark matter became fixed. So where does dark energy fit in all this? Dark energy wasn't even discovered until 1998. Observations made it clear that the universe was not just growing larger, but also at an accelerating rate. All the known matter that we can see, planets, stars, and entire galaxies should be pulling in on the universe, not pushing outward. In fact, the accelerating expansion of the universe was a huge surprise to scientists. It was then that astrophysicists came up with dark energy to explain the strange behavior of the universe. Filling all of space, dark energy's negative pressure is inflating the cosmos like a balloon and interacts very little with gravity. And now, astronomers think they might have just discovered dark energy right here on Earth by accident, using a method to find dark matter. In 2020, physicists utilizing the Xenon 1T facility reported that the experimental dark matter detector picked up a strange signal possibly hinting at new physics. However, a little time after the experiment, the physicists were now saying that the experiment might have picked up the first direct detection of dark energy, the mysterious force that is accelerating the expansion of the universe. The experiment was essentially a big tank full of liquid xenon kept deep underground. The idea of the experiment was that if a dark matter particle zipped through the tank, it would excite the xenon atoms to produce a flash of light and free electrons, and a suite of sensors would detect it. But other known particles could have the same effect. So, putting the experiment underground helps reduce the probability of unwanted noise, but not all. With this, scientists calculate an expected background level of events, then check if the actual detections are higher than this. When they checked, they were surprised to find an excess of events, 53 to be precise, over the expected background of 232 events. Something strange seemed to be happening, but was it dark matter? The leading candidate at the time was a hypothetical elementary particle called a solar axion, which, as the name suggests, would be produced by the sun. They aren't considered to be a dark matter candidate, but other types of actions are. Finding evidence of these actions would be a major step towards finding the elusive dark matter particle. But after further investigation, it was found that far too many solar actions would be needed to produce the observed signal. It was at this time they suggested a different culprit, a force carrier particle for dark energy. Some astronomers have their doubts and say if its true dark energy has been found, it's a stunning discovery. But a lot more needs to be verified before coming to this conclusion. Directly detecting dark matter or dark energy will be one of the most important discoveries of all time, but it's no easy feat to find something that's invisible and barely interacts with regular matter. By 2025, NASA will launch a new telescope designed to unravel the mystery behind dark matter, the Nancy Grace Roman Telescope. When astrophysicists finally do find dark matter or dark energy, we'll be here to tell you about it. So make sure to stay tuned here, and thanks for watching Dark Core.